we will back to the covalent again, yeah. So covalent bonding is the sharing of electron between atoms. This type of bonding occurs between two atoms of the same element or element close to each other in the periodic table. Normally, it is between non-metal with another non-metal. However, there is also some exception, such as in BCl2 or AlCl3. Okay, so for now, we just use the common scenario between two non-metal. Now we can understand how covalent bond is formed by using dot and cross diagram. Dot and cross diagram basically is only a model to represent how electron is shared. For example, here you can see for hydrogen. From this structure, you can see that hydrogen has one electron, right? And to become duplet, hydrogen need to have two electrons. So hydrogen need to get one more additional electron. And how do they achieve that? Hydrogen will react with another hydrogen. They will create covalent bonding by sharing the electron. And we can use the model here by using circle. If the circle overlap like this, now we can count there are two electrons. Remember, this dot indicate electron and cross also indicate electron. Sometimes we use different symbol that's to distinguish which one is electron from the atom, from this atom, let's say, and which one the electron from the other atom. Because this is the hydrogen we are supposed to use the same symbol, right? But in this case, there is a slightly different only to show the electron. Okay, so the same thing happened here because this hydrogen also want to achieve duplet, the electron should be shared between two atoms. Now you can see here there is overlapping, right? There is overlapping area. This area is called by covalent bonding. These two electrons are shared between two hydrogen atoms. Because there are two electrons involved, the type of bonding here is single covalent. Now let's see the other example. For example, oxygen here. Oxygen, based on the configuration, has configuration 2,6. Based on the electron configuration, we know it is 2,6. So to become octet, oxygen needs to have two more electrons. And how do oxygen achieve that? By sharing electron with the other oxygen. So you can see here in the overlap region, there are 4 electrons are shared. These 4 electrons are shared indicate double covalent bonding. So single, double, and triple, that is determined by the number of electrons shared. Okay, and the last type of bonding, the last type of covalent bonding is triple. And you can see here the example for nitrogen. Nitrogen has 7. The configuration is 2,5, the configuration of the electron. 2,5. So to become octet, this 5 electron should get additional 3 more electrons. And how do nitrogen achieve that? By sharing the electron with the other nitrogen. Since there are 6 electrons are shared, this is known as triple covalent bonding. Okay, remember, dot and cross diagram is only a model that can be used to explain about covalent bonding. The overlap region indicate electrons are shared between two atoms. And then if you have electron in this area, this is not overlap, right? This is not shared with the other atom. We call this electron as the lone pair electron. And how about the electron that are shared? We call this as bonding pair electron. bonding pair electron. I repeat, if electrons are shared, we call this as bonding pair. And if electrons are not shared, we call this as a lone pair. Okay, now let's continue. If you look at this question, they ask you how many electrons are used to form covalent bond in molecule of methanol. So let's draw the structure first. Methanol has one carbon. So carbon will be in the middle, and then you have hydrogen on the left, hydrogen on the right, sorry, hydrogen on the left, on the top here, the bottom here, and then oxygen, and then hydrogen. Some of you may be wondering why the orientation is like that, why the position is like that. Remember the idea from proton number. Carbon has 6 electrons, so to become octet, carbon need 4 more electrons. Therefore, you have to position the carbon in the middle. And then hydrogen has only 1, so the configuration will be 1. Therefore, hydrogen should be in the edge or in this side, okay? And then oxygen has 8, so the configuration will be 2, 6. Okay, I want to circle this number. This is going to be important. We must know carbon has 4 in the outer shell. So I'm going to use 4 dots. I'm going to use blue dots. Okay, I'm going to change the color. I will use red for the hydrogen. I'm going to have red for the hydrogen. And then I'm going to use green for the oxygen. Okay, oxygen has 6 electrons, so I'm going to have 1 here, 1 also here, and then 2 on here, and also 2 here. And then for the other hydrogen, it should be the same, but I just want to make sure the visual is good. It can help you to understand, so I will rewrite with different color for the symbol of the element. And then I'm going to use red now, and I'm going to erase this also. Okay, so here I have hydrogen, 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 and here also hydrogen. Now, for the overlap, for the circle, I'm going to use a different color, black. And remember the idea, hydrogen want to achieve duplet. Hydrogen want to achieve duplet, so the circle will be like this. Hydrogen will share 1 electron with oxygen, and oxygen actually also love it because oxygen is also non-metal. To become octet, oxygen need to gain electron. Okay, remember configuration. And then now, okay, oxygen also want to achieve octet. And how oxygen achieve that? By sharing the electron with hydrogen also. If you look at this number, if you count now, oxygen has 7 already. We got 6 green and then 1 red, but because it is overlap, it is also counted as electron share. And then to get octet, oxygen just need 1 more electron because 6 plus 1 is 7. And then get 1 more electron from carbon. Okay. If you count now, hydrogen is already duplet, which is stable. Oxygen is already stable, which is octet, 8. And then how about the carbon? Carbon also want to achieve stability, stable by sharing the electron with 1 hydrogen, sorry, will sharing the electron with 3 different hydrogen with each electron is shared with each hydrogen. And then to become octet, carbon also share one electron with oxygen. Now you can see here the total number of electron is already 8. 2, 2, 2, and also 2 here. So the total is 8. How about for the hydrogen? Hydrogen here also will do the same. Will share electron, right? Already share the electron. So carbon already share the electron, and hydrogen just need to make another circle. Yeah, here. Basically, the circle only indicate electron are shared. Okay, so like this. All right, this is the structure of methanol. The question is, how many electrons are used to form covalent bond in a molecule of methanol? Now we can count how many electrons is required. Here we got 2 electrons. Here we got 2 electrons. Here also 2 electrons, because this is the number of electrons that we use to make covalent bond. This is also 2. This is also 2 electrons, and this is also 2 electrons. So the total now is 1, 2, 3, 4, 5. So 5 times 2 is 10. So the answer for this question is 10 electron.